All right, so we're looking at our end of term revision here. And we have our first question, which is to divide 4x squared minus 25y squared by 2x plus 5y, and then factorize, hence factorize 4x squared minus 25y squared. Finally, divide 4x squared plus 25y squared. Notice that the sign changed there by 2x plus 5y, and hence derive the results. So hence derive the results in part B. So let's look at our solution. So to begin with, we're going to start by dividing. We're going to start by dividing here. 2x into 4x squared is going to give me 2x, right? Now, if you're not certain or you can't work this out mentally, then I suggest you write them as fractions and reduce them, right? So we're going to get 2x, and if we multiply, you're going in, out, and if you multiply 2x by 2x, that's where we're going to get that 4x from. Now, there's a term that will be missing in the middle. When we multiply 2x by 5y, we get an xy term that is not explicitly stated in the question, because the question is the difference of two squares, right? 4x squared and minus 25y squared would suggest that we have the difference of two squares happening there, right? You'll realize that. So in the middle, there's a term. When we multiply our let's make sure, right? When we multiply our 2x by this 2x here, this is how we get in our 4x squared. And then 2x by this plus 5 here is giving us a positive 10xy. This is why I have this 0 here, because I do have a term here to match with it. Now, we need to do that so that when we work things out, we will know what we put in here as our next term. So 4x squared minus 4x squared will give us 0. That will cancel out. And then 0 minus 10xy will give me negative 10xy. This is an important term here because that's going to help us determine what is the next term in our quotient. All right. So 2x into negative 10xy. So if you're not sure about it, you write it out like this. And you could cancel. And that's how we get in this negative 5y here. Now, when we get this, we're going in, out, and then back in. So negative 5y by 2x is giving us the negative 10xy here. And then negative 5y by positive 5y is giving me a negative 25y squared here. And this is how I could bring this down here now. Now remember, you're taking away, right? This is another part students tend to make a little mistake with. You want to remember your signs. The minus 10xy minus 10xy here again. Right? That's going to give us a positive here, and that's how we're going to end up with 0. Same thing going to happen here. Minus 25y squared minus 25y squared. The minus and the minus here is giving us a plus, and that's how we end up with 0. So, this here is another factor of our term, our 4x squared minus 25y. So, they said to factorize it. So now that we have identified that when we divide 4x squared minus 25y squared by the 2x plus 5y, we are getting 2x minus 5y. That's our quotient. If we carry this across our equal sign, this is how we factorize it. And again, we can tell because it's the difference of 2 squared. Everybody understand that? All right, let's look at part C. Part C is the same thing, except that here, instead of a negative 2y squared, we now have a positive 25y squared. So that changes things a bit. Now, we will get the 2x minus 5y, as you can see on top of here. But now, look at what is happening. Whereas this was a negative before, and when I do the negative, by a negative, I get a positive and it'll cancel out. I am now remaining, or I am ending up with a remainder of 50y squared. That's the difference there. So just as we did before, if you look up here, when we divide the 4x squared minus 25y squared, we divided by 2x plus 5. Here we're going to write the same thing. 4x squared plus 25y squared divided by 2x plus y is equal to my quotient and the remainder, plus the remainder. Yeah? Now we're going to move this across just as we did before. And we're going to get this. And then we're going to take this from here, this plus 5y, plus 50y squared, and we're carrying it back across on this side. This is coming across here to give us negative 50y squared. And then we could resolve the two, and this is going to take us back to our 4x squared minus 25y squared. Is everybody clear on that? Yeah? Okay. All right, so let's look at this one. They said find the quotient and remainder when the quartic polynomial 2 to the 2x to the power of 4 plus x cubed minus 2x squared plus 3x plus 2 is divided by 2x plus 1. This is a monomial. This is a quartic polynomial. So when we divide this, we should get a cubic polynomial. Right? So let's go take a look at that. Now, when we have descending powers of x, if there's a one missing, we try to leave that space there, right? So, I start in here. We go in 2x into 2x to the power of 4. When I divide those two, right, we're going to get x to the power of 3. I want to line up the similar powers of x, right? It's a good practice to do that. We're then going to multiply the x cubed by the 2x, and that's going to give us back the 2x to the power of 4. This is going to allow, when we subtract this here, to eliminate this. And x cubed by plus 1 is going to give me x plus 3. When we subtract this, you're also going to get 0 here as well. So this and this is out. I am bringing down next my minus 2x plus 2. But when I say 2x into minus 2x, I am going to remain with a x. Right? This is going to cancel. Right? X will cancel here. Remain with a negative x. Sorry. Notice that I'm leaving that little space blank there. And I'm writing the x in line with the other power of x. Yeah? Then I'm going to multiply negative x by 2x. That's going to give me negative 2x squared. I'm seeing a little square here. And then negative x by plus 1 is going to give me negative x. Now, when I subtract, this is going to go. This will cancel out. I'll get 0 there. And then I'll have 3x minus minus x. The minus and this minus here is going to give me a positive x. And 3x plus x will give me 4x. And that's where I get any 4x from. And then we're going to go out again. 4x divided by 2x. So 4x divided by 2x, my x's will cancel. 2 will go into 4 2 times. This is where I get my positive 2 from. And then when we multiply out now, 2 by 2x is giving me 4x. And 2 by 1 is giving me 2. 4x take away, 4x will be 0. 2 take away, 2 will give me 0. And that's how I'm going to divide that quartic polynomial. My answer here is going to be x cubed minus x plus 2. Right, that's my answer. Everybody all right to that? Yeah? All right, so we're looking at remainder theorem now. Find the quotient and remainder of the quartic polynomial 3x to the power of 4 plus 2x to the power of 3 plus 9x squared plus 2x plus 10 divided by this quadratic here, 3x squared minus x plus 4. So this is what our solution is going to look like. We want to begin by dividing this 3x to the power of 4 by 3x squared. And I wrote the fractions on the side so we could actually see what we're getting. Now remember the rule. Remember what I mentioned before. If my answer is x squared, I want to kind of pair up the x squareds together. I want to put them in the matching powers of x, so to speak. So x squared by 3x squared is going to give me 3x to the power of 4. And x squared by negative x is going to give me negative x cubed. And then x squared by 4 is going to give me 4x squared. So we all have matching powers of x here, right? So we don't need to leave any spaces. Everything is lining up quite nicely. 3x to the power of 4 minus 3x to the power of 4, that's going to cancel out. We're going to get 0 there. Plus 2x cubed minus x cubed. right? And I have that right across on this side here. So you can see our working. That's going to give us a positive 3x cubed, right? And it might be a good idea to do some working like this so you don't make mistakes with your signs, right? Because that's usually where the errors occur. And we also have our x squared by plus 4. That's going to give us positive 4x squared, right? 9x squared minus 4x squared is going to give me 5x squared. So this is what I'm actually getting from the subtraction of these three terms here. And I am bringing down, you can see my orange arrow bringing down my 2x. So 3x cubed minus 3x cubed is going to give me 0. 5x squared minus x squared. That's right here. That's going to give me 6x squared. I'm writing that here. And 2x minus 4x, I am going to get a minus where a positive is a negative. And 2x minus 4x will give me negative 2x. So this is what I'm getting from this here. And I'm bringing down my 10 with that orange arrow. I'm then going to go again. Right? We're going to go again. And we're going to go with 3x squared into 6x squared. Now, 3x squared into 6x squared is going to give me 2. See my 2 here? And then 2 is going to multiply out by everybody here. So 2 by 3x squared will give me 6x squared. 2 by negative x will give me negative 2x. And 2 by 4 is going to give me 8. Now, when I subtract, I'm going to get these here. Going to give me 0. And 10 take away 8 is going to give me 2. So we have our quotient and we have our remainder. Yes, and that's the quotient and remainder for this one. Everybody okay with that? All right, lovely. So let's look at the solution to this one. We have x cubed minus 2x squared plus kx plus 3 is divided by x minus 1. The remainder is 3. Find the value of the constant k. So first of all, we're going to let px equals x cubed minus 2x squared plus kx plus 3. Now, we are dividing this by x minus 1 and we are getting a remainder of 3. So what we could do is we could, 1, change this x minus 1 to work out, well, okay, what's the value of x I need to substitute into here in order to end up with that remainder of 3. Right? And that value is going to be 1. I'm actually just moving the, if I put x minus 1 equal to 0 and I shift this across, I'm going to get x is equal to 1. So p of 1, right? We write it as a function. If we find p of 1, it is equal to 3. Right? So let's first begin by finding p of 1 here. So p of 1, we're going to get 1 cubed minus 2 by 1 squared plus k by 1 plus 3. That's going to simplify to k plus 2, right? 1 minus 2 is going to be negative 1. 3 take away 1 is going to give me positive 2. So p of 1 is equal to k plus 2, but p of 1 is also equal to 3. They said that there's a remainder of 3. So then k plus 2 is equal to 3. And just as we did up here, we could carry this 2 across and we get k is equal to 3 minus 2. And our value of k is going to be 1. Everybody cool with that? All right, so we're going to remain the term again, a slightly more difficult or challenging question. We have here 2x cubed plus 4x squared plus kx minus 7 is divided by 2x plus 3. The remainder is 5 3/4. Find the constant k. Now, the only reason it's slightly challenging is because of the fractions. And I know you all already like to work with fractions too much. But the process is pretty much the same, right? We're seeing basically here, we could let our polynomial be equal to p of x. And when p of x is divided by 2x plus 3, the remainder is 5 3/4. Now, we're taking this 2x plus 3, and you just want to find the value of x that we could substitute in today. So we put it equal to 0. We carry this across. We're going to get negative 3, and then we divide throughout by 2. So the value of x that we want to substitute into our function now into this polynomial is negative 3 over 2. Now, when that is substituted inside of here, the remainder is 5 3/4. right? Now, I prefer to work with improper fractions rather than mixed numbers, so I'm just going to change this to 23 over 4. Now, if we substitute this negative 3 over 2 in every spot we see in our x's, this is what's going to happen. You're going to end up with negative 27 over 8, 9 over 4. Here we're just going to multiply negative 3 over 2 by k and negative 7. So you work it through. Right here, we're going to get negative 27 over 4. The 4s will cancel. Here we get 9. You have negative 3 over 2k minus 7. We could work out this and this together. That's going to give us a positive 2. Then I'm going to use my equivalent fractions to simplify this part here. Right? All right. We write this as 8 over 4. I'm going to get negative 19 over 4 minus 3 over 2k. Now, remember we said that when we simplify this, it is equal to 23 over 4. So I'm going to put it equal to 23 over 4, and I'm going to solve for my k. Right? When you move the 19 over 4 across, it becomes positive 19 over 4. When we add 23 and 19, we're going to get 42 over 4. Right? If we divide that by negative 3 over 2, because I need to move this on this side here, we're multiplying, so when I come across, I need to divide. Right? We divide in fractions. We're going to change this to multiplication, flip this. And when we simplify, we're going to get k to be negative 7. Everybody right with that? Lovely. All right, so now we're looking at the factor theorem. We want to determine whether the g of x is a factor of p of x. So what's supposed to happen is that if we were to substitute our value of 2 here, right? So g of x is given as x minus 2. If g of x is a factor, then when we rewrite this as x minus 2 is equal to 0, and we put x to be 2 inside of our function here, p of x, then p of 2 should be 0. So we need to test to see if that's the case. So for p of 2, I'm getting a remainder of 1. So that means that x minus 2 is not a factor. Now, when g of x is x plus 3, and we transpose here and we get x is equal to negative 3, when I substitute that into my function, I am getting a 0. So x plus 3 is a factor. Yeah? No. If we need to find the other factors of 2x cubed plus 6x squared plus x plus 3, I'm taking it a step further here, right? We could then use this factor, which is x plus 3, and we could divide that polynomial, 2x cubed plus 6x squared plus x plus 3, and we will find the other factor of the polynomial. So when we fully factorize this, what we will get is x plus 3 and 2x squared plus 1, right? So I just went a step further here to show you how you could find the other factors of the polynomial using the factor theorem. Yeah? All right, so here we're going to look at another question using the factor theorem, and we're going to use the factor theorem to completely factorize the polynomial. So we have p of x is equal to x cubed plus 9x squared plus 23x plus 15, and we divide in this, so we want to show that g of x, which is x plus 5, is a factor. So we can let that polynomial be equal, p of x be equal to p of x, right? And we're going to rewrite g of x so we could find the value of x that we want to substitute in here. Now, when we substitute x to be negative 5 into this polynomial p of x, we are getting 0. So it means that x plus 5 is a factor, right? Now, to find the other factors, we're going to divide this cubic polynomial by x plus 5. Being a cubic polynomial, when divided by this monomial x plus 5, what we will get is a quadratic. Now, we need to further factor that quadratic so we could list all 3 monomials that are the factors of this x cubed plus 9x squared plus 23x plus 15. So when I divide throughout here, x into x plus 3 is going to give me x squared by x is going to give me x to the power of 3. Then I'm going to multiply this x squared by 5 here, and I'm going to get 5x squared. We're subtracting on this side here. X cubed minus x cubed will give me 0. So just slash that out. 9x squared minus 5x squared is going to give me 4x squared. I will then say x into this 4x squared to give me 4x up here. And then I'm multiplying out again. 4x by x to give me 4x squared. 4x by plus 5 to give me plus 20. I'm bringing down this 23x. 23x take away 20x will give me 3x. And then I'm back here again. X into 3x to give me 3. Then 3 by x to give me the 3x. And 3 by 5 to give me the 15. Bring this 15 down, I'm getting 0. Right? We're supposed to get 0 because x plus 5 is a factor. What this is going to give me, though, is a quadratic to the top. This is actually the other factor. Now, all we need to do is to take this quadratic, right? Take that quadratic, and we are going to factorize it. So using our first by last method, 1 by 3 will give us 3. The middle term is 4. So we could use a 3x and a x. Yeah? That's going to factor to give me x plus 3 and x plus 1. So to fully factorize this polynomial, we will get x plus 5 into x plus 3 into x plus 1. Yeah? And that's fully factorized. Let's look at the second one quickly. So we have 3x cubed minus 8x squared plus 3x plus 2. And we're given that g of x is equal to 3x plus 1. So similar to what we did before, I'm going to rewrite my polynomial as px is equal to 3x cubed minus 8x squared plus 3x plus 2. And I'm going to rewrite this. I'm going to shift the 1 across. I'm going to get -1. Shift the 3. I'm going to get -3. So when I substitute this value of x into this polynomial, I am supposed to get 0 because they're saying it's a factor. So we need to check it to see if that happens. So I'm substituting, and you're going to have to do a little bit of work in here. I think you could work this out on your own. What is going to happen at the end is that I am going to end up with -18/9 plus 18/9. All of these negative values here will add up to -18, and this is going to give me 0. So it is a factor. So what that means is that when I divide this polynomial by 3x plus 1, I will get 0. So we're going to do the division. We looked at a division previously, so you have an idea how to do your division. I'm just going to jump straight to this part here. We're going to get this quadratic, x squared minus 3x plus 2. Using our first by last method, right? 1 by 2 will give me 2. I'm looking for factors that could give me a -3. Let's use a -1 and -2. We rewrite it in our second line. We factorize by grouping. Right, we're going to pull out our x here. We'll get two similar brackets, x minus 1. And we're going to put this x and this -2 in another bracket. So fully factorized, we are going to get these three monomials, which is 3x plus 1 into x minus 2 into x minus 1. And as a fully factorized form, or us fully factorizing our polynomial that we got in our question. Yeah? All right, so that's our answer, final answer then. Just bring it back up. All right, this is where we ended.